So previously we already learned how computer represents numbers and performs some computation on numbers. However, um, nowadays when we work, computers will work with a lot of different types of multimedia, such as text, images, videos, and audios as well. That's why I want to learn how computer represent those kind of multimedias in this video. So let's just look at the first thing is representing text. So computer are going to represent text using um, many different standards, but the common one is the ASCII standards or its extended version. So ASCII stands for American Standard Code for Information Interchange, and its extended version has 8 bits, or it can represent 2 power 8, which is 256 different symbols. So let's just give some examples that we're going to have 2-bit sequence like this and like that, which is 0, 1, all the 0 again, and the last bit is 1. Another bit sequence of 8 bits is 0, 1, then all 0, then 1, and the last bit is 0. Then this number, we're gonna times them with their position values, and we'll find out this one is represent 65 in decimal system, and similarly, the second bit sequence is represent 66 in decimal systems. Now, if we apply the translation or the 65 of this bit sequence or 66 of that bit sequence through ASCII, the computer will say, okay, if I see 65 or if I see this bit sequence and if I am using ASCII standard, then it's going to be represented as A. And similarly, if I see this bit sequence or it is 66, then ASCII gonna tell the computer that you are working with the letter B. Okay, so ASCII is this is one simple table for ASCII, and you'll see what is the decimal values, what is it gonna represent, what's the decimal values, what is gonna represent. Then we'll see the 65 or 66 something is down there. Okay, then that is how it's represented. But the next one is computer can work with a lot of different characters and letters from different countries. So 8 bits is going to be able to represent 256 symbols. Is not enough to represent all the text in the world, and that's why the another version to represent text is called Unicode. It works exactly the same way as ASCII work. However, it has more bits. That's why it can represent more symbols. Let's say we can represent this kind of symbols using Unicodes. Now, besides text, computer gonna have images as well. So we'll look at the how computer represent images, and computer represent images using every dot inside here, which is called pixel, or it is a picture element. Then for the how pictures, it's actually the arrangement of columns and rows of those pixels. And one term is called display resolution, is the number of columns times the number of rows. Then one common standard to represent images is RGB color images. And what is this RGB color images? It's going to have 8 bits. So it's going to have 256 levels of redness in one pixel. Similarly, it's going to have another 8 bits for different level of redness, greens for a pixel. Also, it's going to have another 8 bit to represent blue for a pixel. Let's just take one pixel here as an example with that color. It's going to be split into three components as red, green, and blue. And for that pixel, for this pixel with that color, it's gonna have full red in it and almost full green in it, and it's about halfway of the blue in it. Okay, so if you have 255, then that one is full of red, and if you have 0, then it's black. Let's say similarly, if you have 255, then it's going to be full green, and if you have 0, then it's going to be black. So if you go from 0 up to 255, it's going to just smoothly transfer from black to green. So again, get back to this pixel. It's represented by 255 of red, 232 of blue, and 137 of 232 of green and 137 are blue. And these are actually translated into three bytes. First byte is for the red, it's going to be all 1 for 255. The second one is going to be almost all 1, especially the significant bits, because it's a big number, and that one is a bit sequence. And the third one is this bit sequence. So for this one pixel, we're going to use 3 bytes of 0 and 1 like this to represent that color. Okay, and if we have a picture, we'll have a lot of them. That's why we need to have image compression. So let's just say if this image is 1920 by 1080, which is the common image resolution or computer resolution, then we'll have that big number of pixels. And each pixel there are 3 bytes, 1, 2, 3 bytes, and it's going to be about 6.2 megabytes of this size. Therefore, image compression techniques are important. We need to have this technique, and the common techniques include JPEG or PNG. Okay. So this is a summary of representing images. I just summarized them in text for you to read. So the next one is representing videos. So representing videos is simple. It's just representing multiple the images at different timestamps, or we call them as moving images. And there is a new term over here, which is frames per second. And normally for videos, you're gonna have 30 images per second. And again, you'll have a huge amount of images for video. Imagine that we have 30 images per second. So that's why there are different video compression techniques is important. Let's say you may have MPEG, or you may have MOV for QuickTime, or so on and so forth. Now, the next one is representing sound. Because we work with computer, beside images, videos, text, we work with sound as well. So the sound is actually described by the amplitudes or waveform samples over time. So when you see sound, actually you'll see actually it is a waveform like this. In computer, it's going to be represented by the amplitude of this waveform over time, but we cannot represent all the possible values over time. That's why we need to sample discrete some point in time. Okay, at some point in time, we're going to sample what is the amplitude. So the sampling process happens this way. Some point in time, we sample for the amplitude, some point in time, sample for the amplitude, and so on and so forth. Then from there on, we have now the description of the sound in terms of the samples, amplitudes of the waveform. So Specifically, we're going to use a number for the amplitude, and again, the number is represented in terms of bits. So the number of bits for the values for the amplitude values determine the unit slivers or, the amplitudes or the quality of the sound that we can describe. So again, sound is also large in size. That's why some compression techniques is important, and one of them is the MP3 compression technique. So here is a summary of how do we represent sound.